In this video, we're going to look at the derivative of the natural log of x. And so the idea is this. If we know that the natural log of x looks like this, or something like it, then I know that I start with a very steep slope here and slowly get closer and closer to a horizontal line. I never get there. The natural log of x is always increasing. But that leads me to believe that the derivative looks something like this. And so, at least when I'm dealing with positive x's, the derivative with respect to x of the natural log of x will equal just 1 over x. Now, I'm going to go into a quick proof. As with all my videos, if you'd like to skip the proof, look in the description. There will be times to the examples down below. But here is a proof of it. So let us let y equal natural log of x. And when I'm starting this proof, I don't yet know that the derivative of that will be 1 over x. But what I can do is say this. Okay, if y is the natural log of x, that means that its inverse, e to the y, is equal to x. And I can take the derivative of e to the y. We've already dealt with that in the previous video. So I'll take the derivative of this with respect to x, and the derivative of e to the y is e to the y. But since the y and the x are not the same, I multiply that by dy dx. The derivative of x with respect to x is 1. And I can divide both sides by e to the y and get that dy dx, or the derivative of this with respect to x, is 1 over e to the y. Notice our original problem had nothing to do with y, so I don't like this y here. But also notice that y equals natural log of x. So this will equal 1 over e to the natural log of x. And since e to a power and the natural log of something are inverses, this will just be 1 over x. So looking at a couple of examples. First example, I want to find the equation of the line normal to y equals natural log of x squared at x equals e to the 4th. And so I need to find the point. I'll do that first. So I'll evaluate y at e to the 4th, the original function. And that's just going to be the natural log of e to the 4th squared, which will be the natural log of e to the 8th. And because of the fact that natural log and e to the power are inverses, this will just be 8. So our point is going to be e to the 4th, comma 8. Next up, we need our slope. So I'll take the derivative of this with respect to x. Well, the derivative of the outer function, the derivative of natural log, is 1 over the inner function. And then I need to take the derivative of the inner function using chain rule, so I multiply it by the derivative of x squared, which is 2x. And that's going to reduce down to 2x over x squared, which is just 2 over x. Now I'll evaluate this, so the derivative with respect to x evaluated at x equals e to the 4th. And that's just going to be 2 over e to the 4th. Finally, I can get to the normal line, so y equals, the normal line has the opposite reciprocal slope, so I'll have negative e to the 4th over 2, x minus e to the 4th plus 8. And there is my normal line. One more example, just to see a nice, interesting thing that happens. If I'm taking the derivative of this, so I have chain rule with 3 links in the chain. So I take care of the outer function first, which is natural log, and its derivative is just 1 over the inner function unchanged. I multiply this by the derivative of the next inner function, the derivative of sine is cosine, and I leave its input unchanged. Then I multiply this by the derivative of x squared, which is 2x, and I can multiply these into the numerator because it's the same thing as cosine over 1 and 2x over 1. So I'll get 2x cosine of x squared over sine of x squared. And one last thing, and I'd be fine with this answer, I suppose, but on the AP test, they might not have this as the answer on the multiple choice. I noticed that I have a cosine of x squared over sine of x squared, and that is the same thing as 2x cotangent of x squared. Alright, I hope this helped out. Feel free to comment below if you do have any questions.